Hello, welcome to Howdy Partner. This is a show where we talk about some of the cool things our partners are doing in the community. And today we have Pulumi back on the show. So would like to welcome Lee back on the show. And today we're going to be talking about a bunch of cool things. But Eugene, walk us through what we're going to talk about today and what people should be expecting from tuning in today's episode.
Yeah. So today, trying to go back a little bit more. In December last year, in December 1st, during reInvent, AWS announced the kind of new Lambda container features. And so today, to kind of give you like a brief overview, what we're going to be talking about, we're going to give a bit of an overview of what Lambdas are and what containers are, and kind of how that kind of groups together. And Andrew will kind of go through like a demo of a quick serverless app that he created using some of the serverless application model. And after, we're going to invite Lee to kind of go through how Pulumi, to go over what Pulumi is, what do they do, and kind of like what uses and integrations they can have with the Lambda containers.
But before we do that, let's take a step even further back. My name is Andrew Park, and I'm a Partner Solutions Architect here with AWS. And this is my colleague, Eugene Mu, who is also a Partner Solutions Architect here with AWS. And so if this is your first time joining the stream, make sure to like and subscribe for more content that we're producing for 2021. But Eugene, Lambdas and containers, it's typically two things that don't go hand in hand. And a lot of times you'll see on Reddit or Twitter, like, you should use Lambda for this. No, you should use containers for this. Serverless is better than containers, and vice versa, right? And so, when I first heard about this announcement and I like dove into a little bit more, I felt like kind of dirty, like being able to package my Lambda function like as a container. It's just like, I was like, wow, like this is like a real thing, But if you think about the value in the different business use cases customers can benefit from using something like this, it's huge, right? Because initially, just Lambda by itself has some pretty significant limitations. But now the fact that you can create 10 megabyte container images that contain your Lambda functions is like pretty wild. So if you have really heavy like data-driven applications or applications that require a ton of CPU and memory, like that all becomes possible with Lambda now, right? Because now you can just package everything as a container image, which is huge, right? But to set a little bit of context for folks that may not be as familiar with things like Lambdas and containers and what all this means and how this all plays together, Eugene, can you tell everyone what Lambda is and how that ties into the whole world of serverless?
Yeah, so to kind of walk through like what serverless is, so serverless essentially, although it has the word serverless in it, there are still servers kind of hosting the kind of compute portion of everything. But what serverless really kind of drives home is the idea that it's an event-driven architecture. And what do I kind of mean by like event-driven architecture? Well, I kind of want to bring like an example that you'll probably see pretty often, but essentially think about like an S3 bucket or something that you need to kind of encode or or transcode like certain video files. So if you want to go from like MP4 to like .mov or vice versa, for a use case, when you drop something into a S3 bucket, that is technically considered like an event, right? You're putting something into a bucket, and so then using Lambdas, right, these events can be triggers for Lambda functions to actually run. And so in the example that I'm using, we can be going from an S3 bucket that contains video formats of like a certain, or video files of a certain format. Lambda can automatically be triggered to take these files and transcode it into a different format and put into a different bucket. Now, I'm just using like a pretty like basic example, but when you think about event-driven architecture even more, you kind of start thinking about like things like scaling, right? Like Lambda functions is very, very scalable. And the reason why it's scalable is that instead of kind of producing or auto scaling like a whole bunch of like different servers, what you're doing is function, right? The exact function that you need to do. So now taking it back into kind of like a web application or like a mobile application, when you are signing up for like a certain website, there's nothing that you're really doing, right? You're typing in your information, but nothing is really happening yet. And so the server, like usually like a typical server architecture, you don't really need to kind of like keep hosting like the web page, right? Like you can do that by you can serve static content via like S3 and like CloudFront, things like that. But what the magic happens when you click like a submit button or like the sign up button or like any of these actual like event driven things. And so that's where like Lambda kind of fits in, where you can kind of match a specific function on your website to a specific to actual like to actual like data processing things like in the back end. And so that is a little brief overview of like Lambdas and kind of like the world of like serverless. And so I'm going to kind of throw it back to Andrew to kind of talk about containers.
But before I do that, I just want to go around the table. Let's talk about the first Lambda function you ever created, because Lambda's been around for a while. And there's a lot of practical use cases for using Lambdas, right? And so I know for me personally, I remember in a previous life, I was trying to load an Excel sheet into Dynamo, and I was trying to find like an automate way of doing it because, back then I didn't know much better. So I was literally just manually inputting the data from the CSV file into Dynamo, and it was just miserable, right? And I was spending way too much time on it. And then, you could use like something like data pipeline or whatever, right? But when I found out about Lambda and the different use cases, I was like, oh, like, could I use this to transform my data for me and then upload it to my DynamoDB table? And that just saved me like many hours of just manually sitting there and inputting data, right? So that was my first interaction with Lambda. What about you, Eugene?
Well, I think for me was probably kind of getting into the whole idea of like serverless. So when I was talking about like the web application earlier, this was something like I built like this built this like Secret Santa like web application on like Django like many years back. And as I got more and more into like AWS and the idea of like serverless, I was like, oh, maybe like a cool project would be to transform like this web application into like a serverless application. And so instead of kind of having like a actual like web server that kind of hosts like the application, I was like, oh, we can now break it down into like different pieces, right? Like we can start talking about like using API gateway to start sending like to start acting as triggers for like Lambda functions, because the this web application that I made was like when I first started getting into like programming, so it was pretty basic. And so kind of like, being able to create like a list, add items to the list, right? All these different things now have its own individual Lambda functions to do it. So that was kind of my first foray into like the using Lambdas. And Lee, I don't know if you have any stories that you want to share?
Yeah, I guess like very first Lambda function, probably, I used to work at AWS. So at some point, I think I probably did some Hello World thing at, back in the day.
Yeah.
First time I did it I kind of used Lambda for real was I was building up a side project around trying to create a kind of like a charity website kind of thing, where it was trying to combine this like idea of petitions with donations, like combined. So kind of like petitioning for a cause, but also like donating it was an odd mashup, I guess. Anyways, the API for that I was building on top of API Gateway backed by Lambda. And so the idea was to, for my side project, build a completely serverless API as part of doing that.
Nice.
Awesome.
And so, Eugene, you asked me a question. What is a container? Just to give a little more context for some of the things that we're talking about today. So, I guess at a high level, basically a container is a way for developers to ship their code in a lightweight and portable fashion. And so, if you think about the concept of virtualization, right? If you think about like bare metal servers or just hardware, virtualization makes more efficient use of that hardware, right? So you can spin up virtual machines, and in the world of AWS, that would be something like EC2, right? Is being able to spin up virtual machines very quickly and efficiently. But if you add another layer of abstraction, right, and you decide to virtualize the operating system, right, then you start going into the world of containers, right? Because you can start spinning up more applications on your virtualized environment. And it just makes it a lot easier for developers to push and send code back and forth to trailers. So like, for example, like if I'm working in Python and Eugene is working in, let's say, like Node.js, we can work more efficiently by sending code back and forth because everything's packaged and all the dependencies I need in a Node.js environment will all be included when he ships his code to me, right? So it provides a much more efficient environment for developers to work, right? And that's why we've seen a lot of popularity with containers over the past few years. for dev teams. And so at a high level, that's one of the reasons why you'd want to use containers. And so again, the concept that you can package a Lambda as a container image still blows my mind. And I'm still myself like diving into it and figuring out the different possibilities with it. But I think the main thing to take away is the fact that you can package it as a 10 megabyte image is pretty massive, right? Or excuse me, gigabyte image is pretty massive. But aside from that, Eugene, so we've talked about serverless, we've talked about containers. And so when I think of those two things, I initially think of the concept of microservices, which, you know, in today's day, like you'll see a lot of serverless, you'll see a lot of containers in microservices-based architectures. But to give even more context than we've already given, could you just give a quick overview on what a microservice is and why it's important in today's world?
Right. So I think like, back in the day, the fact that you're able to develop an application with the data, like with the database, kind of serving content on the web is great. And so the fact that we could actually do that kind of created this idea of a monolithic application. And so kind of monolithic application is like the old reliable, but microservices and kind of like decoupling is kind of like now the new hotness in like the tech world. And the reason why is because there are some limitations with like monolithic applications, right? And so with AWS, the idea of decoupling architecture is extremely important because if the architecture is decoupled, then there is less points of failure. And so in a monolithic application, let's just say that the networking, like the web server failed, right? Then you're gonna that application is gonna be bottlenecked at that failure. And so, and not only that, but from like a development point of perspective, if everybody is working in one line, like giant, large code base, people are going to be stepping on each other's toes pretty often. And so the idea of microservices is where you're kind of abstracting or extrapolating and putting different functions into like different services so that like teams can kind of work in parallel. And so the idea of microservices is just like, services making API calls to each other, requesting certain information and getting back certain information, and it's all kind of contained in its own like little sphere. And that has helped both from like a development point perspective, where now like let's say one team that worked on like a pet store app. One part wanted to do some AI ML stuff. Another team was working on the actual web application. There's like another team that worked on maybe like something, some other like, like new crazy service. They're all able to kind of interconnect without stepping on each other's toes. And then more importantly is like the actual website itself, right? That pet store itself. If for some reason like the database layer failed, it wouldn't cause the entire web application to stop working, right? And so this kind of goes back to making sure that you have high availability and that you have like easier time of development. So that's kind of like my little spiel about microservices.
And honestly, like we could probably spend like a whole series of episodes on like the benefits and why you should use microservices, right? But I want to show a little love to containers, and I want to take a step back. Let's go around the table and talk about the first container image that you've ever built or ever pulled down. So for me, I think it was like a few years ago. I pulled down like a simple Flask app from Docker Hub, and I was like, wow, this is actually amazing, and it was like super fast. It didn't require much effort, but it was just like a simple web project. But that's probably the first Docker image I ever pulled down from Docker Hub. Eugene, what about yourself?
So at my last job, we were kind of shifting over our deployment to actually like deploying on ECS or Elastic Container Service on AWS instead of kind of just deploying through like EC2s and not really having and kind of like manually like managing like the instances that way. That it was kind of like my experiences like with containers and ECS as a whole.
Nice.
Emily.
Yeah, I mean, I guess probably, I think if I think back to like back in the day, I guess probably like Nginx, just like, the Hello World,
There you go.
like Docker pull Nginx, right? So that's probably the first container image I pulled. I will make a note that kind of like, at Pulumi, we run part of what we do is we run a software as a service application, and like that application is actually completely containerized and it runs on ECS. So we actually work with containers pretty much every day.
Solid. Okay, so we've given you an overview of microservices. We've given you an overview of what a Lambda is, a container is, and how and why it's important to use both. But before we get into a demo demonstrating like how you can simply build a quick image that's packaged or a quick image that has a Lambda function packaged into it. If this is your first time tuning into the show, make sure to subscribe because we're going to be putting out a lot of great content in 2021. But Eugene, who are we? What are we doing? And why are the things that we're talking about today important?
So I guess like who we are. We're just a bunch of technologists who are interested in kind of like the different technologies that are coming out, and why is it kind of important? Well, I think as Andrew said, the creation of like Lambda containers and images kind of really puts back some of the like pushes back against some like the limitations of Lambda functions, and also it gives it a lot more kind of like variety. There's more flexibility, so that like if there are certain like package binaries and libraries that AWS doesn't support for Lambdas, which are a lot, that kind of goes away with the idea of like Lambda containers. You can kind of also have like custom runtime versions. You can reuse existing like base images, and kind of like what we were saying. I think what Lee and I mentioned earlier in terms of like what Pulumi does with working with containers, and what I used to do as a developer back at my old company, is the idea of kind of like standardizing like development and deployment, and so making that quite a bit easier. And so I think I will throw it back to Andrew, who will kind of start demoing how to create a Lambda container image.
Yeah, so before I get into this demo, one thing that I want to kind of call out before I go into it is we have a tool here at AWS called SAM, also known as the serverless application model. And if you've seen a little squirrel with a little builder hat on with the Lambda function on it, you probably know what I'm talking about. But basically, SAM allows developers and folks that are interested in building serverless architectures and applications an easier way to do so. And so one of the really cool things about this new Lambda container function is you can actually build these container images with SAM. And I didn't know you could actually do that. So I'm going to demonstrate that today, because when I initially found out about it, kind of blew my mind. So if you take a look at my screen, the app itself is pretty simple. It's just a simple Lambda function that generates quote unquote fake data. So the application itself is pretty simple. But what you'll see right next to it is that there's a Docker file, which a lot before this feature came out, a lot of people would raise their eye and be like, what is that? Like, why are you doing that, right? But if we inspect this Docker file, right, let's break it down piece by piece. So the first line of this Docker file is pulling the Node.js as my base image, and so one of the cool things about container workloads on AWS is we have our own public container image registry that you can pull down images that you want. So if you want to use like Flask, Node, or other base images that you want to use, we have that available for you publicly. So in this Docker file, I'm going to pull down Node.js version 12 from the public ECR repository. The next step in this Docker file is that it's going to take all my applications and its dependencies from this file and pull that into my image. The next step here is it's going to install all the npm dependencies that I need for my application to run properly. And then finally, it is going to run the actual Lambda itself. And so real quick, I'm just going to build my image. So docker build /t, and then I think it's just, and the customer function, or no, excuse me, it's get customer, get customer. So what you're seeing here is like, it's just taking my Docker file and it's building my image for me. And so if you're actually doing this fresh, the next step you would actually do here is that you would actually push this image to ECR, or otherwise known as our Elastic Container Registry. I actually already did that because sometimes it can take a bit of time. So I already did that for you. But typically, if you're doing this from scratch, again, the next step you do after your image is built is you would push it to ECR. And so kind of like I talked about before, the next step I'm going to do is I'm actually going to build this with SAM. So I'm going to go ahead and do SAM build. Oh, excuse me. Oops. After I go into my, so SAM build. Cool. And so again, it's a pretty small app, but basically, if all goes well, you should see this build succeeded. it's good to go. So now that now that Sam's built the image, the next thing you obviously want to do is deploy the actual image itself. So let's go Sam deploy. And then it's going to ask you a bunch of questions. So the stack name, yeah, I'm fine with that. I'm in US West 2. That's totally fine as well. So like I mentioned before, obviously you want to push this to a registry, and I already did that for you. So I'm going to leave that as is. That's fine. So I'm going to hit yes. Yes. That's fine. Save arguments to configuration file. Yes. And then typically, if you're using SAM, all of your configurations are going to be saved to a config file, as you see here. So I'm going to leave it as is. Leave it as default. And then, yeah, now it's building. So it's literally that simple to build a Lambda container. It's like literally that simple. And with SAM, it just makes it that much easier, right? And so once that's complete, we can actually go over to the AWS console, which I will show here. And if we go to Lambda, we will see that it has been built. And so if we actually take a look at the overview, what we'll see is that my Lambda function has been created along with an API gateway. And then what you'll now see, now that you can package your Lambda functions as a container image, is that now there's this image tab. And so if you click on the image, it will actually give a link to the specific image that was pushed to my ECR registry. And so at a high level, it's really that simple to build and package your Lambda functions. And so that's just a quick demo on how easily you can do it. There's a lot of documentation and blogs out on the internet right now that can help you, get started with the new feature for Lambda. But with that said, it's really that easy, and it's really that easy to get started with this new feature. So with that said, I'm going to stop sharing my screen, and I'm going to hand over to Lee. Lee, tell us a little bit more about Pulumi, and tell us a little bit more about what you guys do.
And sorry,
Yeah,
Lee, right before, I'm so sorry, but right before you start talking about Pulumi, there's a couple of things about the Lambda containers that we do want to also kind of share, right? And so with Lambdas, you're able to kind of to test pretty easily, but also we want to make sure that you're able to test easily in Lambda containers. And that's why there is the kind of the Lambda runtime emulator, which is basically just a lightweight web server that converts like HTTP to JSON, or can actually even accept HTTP requests as well to test your Lambda function. So to make sure that the Lambda image and like the actual code that you're putting into it has like the expected output, you're able to do that using kind of like common tools like curl, or if you are using like if you're using container image, you can use a Docker CLI. And with that, I am going to really stop talking and pass over to Lee, who is much more.
No worries. No, I was going to just talk a little bit about Pulumi, talk about a little bit about what we do and kind of how we can actually do a lot in the scenario that we're just talking about. So Pulumi is a tool that helps end users use build infrastructure as code solutions and build modern applications in the cloud using the language of their choice. And so Pulumi actually lets you create programs in a variety of languages, including the Node.js ecosystem. So you can use JavaScript and TypeScript. You can use Python. You can use .NET. You can use C# or F#, or even actually someone recently on the team decided to go and build a very scary-looking example with Visual Basic.NET and Kubernetes. Oh. So they actually showed off how you can deploy. It was actually kind of fun because you actually looked at it, like some of the syntax looks kind of like natural in some ways, because like there's this, when you define like dim stuff in VB.NET, like you dim with as, and it looked kind of like okay, this kind of makes sense. But anyways, they did this VB.NET thing that was deploying all these Kubernetes applications, and we also support Go. So we support all those language ecosystems, and you can define infrastructure using those languages. And one of the cool things is you get the benefit of the entire language ecosystem. So you can pull in any library from any of those ecosystems and use them as part of defining your own infrastructure. I think if people on the show are familiar with CDK, it's a little bit similar. There's some differences, obviously, with CDK. CDK, kind of hooks into CloudFormation. Pulumi has its own execution model and engine, and so it doesn't use CloudFormation under the hood, and so it has some differences there as a result, kind of around how the execution actually happens. Like CloudFormation is kind of shipped as one template to CloudFormation. So if you're using SAM or CDK or something like that, that's what's going to happen under the hood. With Pulumi, we're actually making calls against the underlying API endpoints to make those provisioning things happen and kind of do the state transformation. But it's still a desired state model at the end of the day. Hopefully that overview helped, but happy to kind of go into more if people who are watching kind of are confused at all, or if you guys want to dig into anything else. Otherwise, I was going to actually kind of go through a demo of just how to get started using Pulumi, kind of show some of the basics of the Pulumi programming model, and then after that, show how we can actually take some of the concepts you were showing off, Andrew, and do them in Pulumi.
That's good. And then before we do that, if this is your first time tuning into the stream, this is Howdy Partner. This is where we like to bring on our partners to showcase some of the cool things that they're doing. And today we have Lee from Pulumi, who is going to demonstrate how you can package your Lambda functions and containers using Pulumi. So with that said, Lee, do your thing.
Sure. Let me share my screen here.
And for all the viewers, if you have any questions, please feel free to ask them in the chat, and we will be responding to them.
Yeah, so I think what I'll actually do is, like, funnily enough, just run through the getting started, and so we can just talk through some of the stuff here in the getting started as part of kind of getting this going. So with Pulumi, I've already installed Pulumi. You can install it from Homebrew. You can install it through Chocolatey if you're on Windows. You can also run this curl command if you're on Linux, or actually this works on pretty much any platform that has curl. And then you can choose, the language of your choice, like I talked about. I think today we'll probably use a mix of Python and Node today, and then we'll configure AWS. And so you can do this actually a number of ways. Like here, we kind of have one option is to just export stuff. You can also set environment variables. We also do read from your .aws credentials file as well. But let me go into little workspace I created here, and we're going to make it, getting started directory. And so if we go to this next part, it suggests making this thing, and we're going to do this. We're actually going to do this. So we're going to say Pulumi new AWS Python, and oops, am I in the wrong directory? Oh, I'm in the wrong directory. So if I go into this empty directory and actually do this, it'll prompt us with a bunch of stuff. So I'll call it this. We won't change any of these things. And we'll choose the region. We'll say US West 2. And this will create a virtual environment for me along with everything else that I need. And then we can go write our Pulumi program. So let's give this one sec. And so if we go back to these instructions, we'll have these files. There's a YAML file that defines the project, a thing that defines the stack, and then we have this main py program that we're going to actually create our things in. So if I open this up in Visual Studio, so I should have done this part earlier. By the way, I should note this is completely live in terms of, like, I've done zero pre-canned anything. So all of this will be live. So hopefully it all works, but hopefully it also shows how easy everything really is. So I have this basic Pulumi program here. And if we kind of open up a terminal, we can run this program. So if I just do this actually real quick, I'm just going to export some of my credentials so you don't see them. And I have a ton of AWS profiles. I have to choose the right one. Okay, so if we run Pulumi up here, this is going to execute this program that we have up here. And all there is here is just it's going to create a bucket. It's going to be called my bucket within Pulumi, and it's going to actually do what we call auto naming within Pulumi, and so it will create a name based off of this name to actually use. So if we say yes, it'll create that bucket and it'll export the bucket ID. So we'll see that in a sec. And what exports are within Pulumi is, you can think of this as a stack. So this program defines one stack, and one stack might have various, you could imagine using anything in the language to create your stack. So you could have a for loop here. You could, do whatever language constructs you wanted. And then a stack as a concept has a set of outputs. So in this case, we've defined one output, which is bucket name. and that's output here. And if you create another stack, you can reference that output in that other stack. So you can kind of compose stacks together using the outputs from one stack and flowing them into another stack. So like a common pattern, for example, might be you have a stack that represents your common infrastructure stack. So that might define like a VPC. It might define some buckets. It might define some common infrastructure, for your organization. And then you'll have, one stack per application or something like that within that environment. So you can imagine having like a common staging stack, and then your front end staging application that references that common staging stack, a back end application that references that common staging stack as well. So if we actually pop open this in the Pulumi console, one of the cool things here is this hooks up to our SaaS. And so here you can see the stack I created. We have the full history of all the activities. I've only done one thing so far, but if you could imagine over time, there'd be kind of how my stack has transformed over time and the various things. I can click into this update to see, what did I actually do? What were the changes that took place? I had, 2 things were created. And then you can actually also, if I click on resources, I can, pop this open in the console. Oops, I'm not signed in. Let me just sign in real quick. All right. So if I pop this open, then we can go see this in the console, that particular bucket that I created. So let's go back and modify this example. So if we follow the getting started tutorial, I think we did this, and then now we're going to modify the program, and why not? Let's do it this way as well. And so we can actually create a file like this. I think we'll just copy and paste it instead of doing that way. And we can create a bucket object, and here we're gonna define it like this. So actually here you could do this. You could also actually do Pulumi file. Oops, this is important. Yes. And so we can reference that path. Index. And we also need to actually modify the bucket. I don't know if this, interesting, this example doesn't do that. We'll do that in a second. We can also modify that example to make this into a website bucket. But let's run Pulumi up first. Oops. And what you'll see that the bucket already exists. So, it's not going to try to create another bucket again. It's going to just do the difference. Oh, unexpected. This is probably because. Right? No. Let me see. Sorry. Oh, I see. It's because this is a string content, and actually I want to reference this as. By the way, one of the nice things about doing this in a language is you can do autocompletion. And so I think content, I always forget this, content refers to the actual, if you give it a string, you can do content. Otherwise, you have to use source, I think is the right parameter. And so this will pull in this file as the source for this object.
And actually, while it's updating, we have a question in the chat. Does Pulumi have a Java SDK?
Pulumi does not yet have a Java SDK. There's a couple languages that people have been asking for that is definitely on our radar. So not yet. A couple things I guess I can mention there is like, would love to hear people's feedback on what other languages they want. So like I mentioned earlier, we support 4 different runtimes: Node, Python, .NET, and Go. A couple of the higher requested ones that we haven't gotten around to yet are Ruby and Java. Those are probably the kind of 2 top most requested. There's also like some community efforts around potentially bringing those in, because Pulumi is an open source product. So one of the cool things is like we have people contributing various things to our ecosystem as an open source product. So if you're interested in doing the Java side, you could also potentially, if you wanted to contribute like that. So now that I've run the update there, you can see it didn't change anything else. This is the only new object. And now we have this index.html file in our bucket. And so now we can actually go back and if we want, obviously this is not going to serve anything. Like I can't go to this thing and get anything out of it because it's not a publicly exposed bucket or anything like that. But we could also easily transform this into a website bucket by providing like the website endpoint and the domain options here. So actually, I can't remember if the getting started walks through that. Let me check. No, it doesn't seem like we do. But you could do this, for example. Oh, here we go. So we could do this. So we could copy this part. So if we wanted to make this into a website bucket, this is pretty standard. Like you could turn an S3 bucket, an S3 bucket into a website, and then similarly we'd have to provide this this additional set of ACLs to that object. So let's do that too. So you can see all we've done is just modified our program to add this additional argument to say, hey, like this bucket should also be a website bucket. And then we're also saying, give this object that we created a public read, and then also give this content type. And those are the only changes. We'll also do this actually, which is helpful to get the bucket endpoint so we can actually go visit that site. So if I save this and I run Pulumi up, we'll see two changes. We should see a change for the bucket because now we're changing the actual bucket properties, and we're changing the bucket object properties as well. So if we go down here, you can see there's two resources to update. We're going to update the bucket, and it's going to, you can tell from the diff, we're going to add this website property, and we're changing the ACL and content type of the object. So if we say yes.
So one thing I kind of want to like just mention that's like really cool is that you're able to kind of change these bucket properties like kind of programmatically, right? Like I think if anyone were to try to do this like on the console, you'd be going through like 30 different clicks by now. And
yeah, what's cool is that this is all programmatic, and like so I'll show a couple of other things kind of related to that in a second. So if I refresh this, like nothing's really changed here except that this object's properties have changed. If I go to the properties of the bucket, we'll see that should have it has the static website hosting enabled. If I go back here, you can see actually this popped open this thing, and if I click this, like we got the thing that we wanted to serve. Yeah, so to kind of go back to what you were saying, Eugene, in terms of like it's all programmatic. One of the cool things here is this is just a program, and this program represents my stack. So I could just as easily do another, like, so if you look at my command line, I'm going to run Pulumi stack in it another stack, and previously our other stack was called dev, but I have another stack now, and I can run Pulumi up. And this is going to treat it as a completely new set of state. So there's no existing state whatsoever. It's going to create a new bucket with a new object. Oops. So this is a new stack. It doesn't have any configuration either. So let's set the configuration. We set the region to be US West 2. Now I run Pulumi up. And now it's going to say, oh, actually, like, well, for this stack, there is no bucket. There is no object. Let's create those. And we can do that, and we can create this new stack, and we'll have a completely separate clone of what we had just created off of the same program, but the program is completely unmodified.
I guess oh, sorry, no, that's I want you to finish your thought.
No, so a common pattern or use case for this is kind of like there are kind of two ways a lot of our end users use this. One is for ephemeral stacks, like they create ephemeral stacks for their own dev stack. So like for our own SaaS, like I have an ephemeral stack that represents my own dev stack of our Pulumi service, and kind of like I can muck with it and I can tear it down. I can run, Pulumi destroy and tear down my stack without affecting anyone else's. And then the other way a lot of people often use this is to have to separate out staging, dev, and test stacks, and that way all the resources between those stacks are completely separate and kind of not intermingled or related to each other, but they're all built off of the same code, so you know that whatever you're going to do in staging is going to be the same thing you're going to do in production because it is the same exact code that's being run in each case.
Yeah,
Sorry.
actually, I was actually just gonna ask, kind of like, what are kind of like the ramifications of introducing kind of like, infrastructure changes at like the programmatic level? Like, I know we've talked about here on Howdy Partner with other partners about things like, security, like, being able to even just pull, like, being able to like code review, like, hey man, like, it looks like you're about to delete this entire bucket. If you delete kind of like your bucket object, you go empty
Right.
that bucket object, right? So just wanted to ask that question.
Yeah, that's a great question. Tons of our end users use this in a very like GitOps oriented way, and in code review. So actually, like maybe one interesting example is like we have get.pulumi.com, which serves the actual script to download Pulumi. That's an open source repository. And so if I go to get.pulumi.com, let me bump up my font a little bit. So actually, like if we go look at some previous pull requests. And I'll just pull up a random one for this repo. One of the things you'll see is like this Pulumi bot will leave a little preview comment here, which shows like, hey, based on the change you made in this pull request, this is what we expect to happen to your infrastructure. And so in this pull request case, this person was changing a shell check reference inside a file. And so that change actually will result in this particular resource, this bucket object, to change. And so the preview actually in the pull request even shows like, hey, if you approve this and you merge this change in, this is what's going to happen. And so like that's a pretty common workflow for our end users to do something like this. And often like, so for example, if I were to click through to this, I can actually see that particular stack. And actually earlier I was talking about kind of like the activities and things like that. You can see all the various changes over time and click into any one of these and see, what actually did change, and to get an understanding of like what's actually happening across your stacks and how that stack is changing over time.
Cool.
Cool. So I think really like as far as the intro to Pulumi goes, I'm going to stop here, and we're going to go now to do the fun Lambda container stuff. So I guess if there are questions from the audience or from you guys, maybe this would be a good time. But otherwise, I will move on. And
actually, I do have a quick question. So when we talk about the concept of stacks and working across multiple developer teams, I was just curious, how does Pulumi handle drift detection?
Yeah, that's a great question. So a common way is like people will often run Pulumi refresh. And so refresh goes and reads the state of what's in the cloud and compares it to the state that it thinks that things are in. So if I run, let me just select the other stack. So if I run Pulumi refresh, this will actually go and read like what's the current state of the bucket, what is the current state of the bucket object, and compare against like what it thinks it should be. And you can see here, like there are something that S3 automatically sets that I hadn't set myself, and it notices those as diffs because I hadn't set them. And so kind of over time, typically what will happen is like, let's say yes, it'll kind of add those to my state. But the other thing that people typically do is there's an option here called expect no changes. And so one thing you can do as part of like a CI/CD workflow is in your CI/CD workflow, you would run Pulumi refresh expect no changes before you do anything. And so basically like, hey, before I even try to change anything, I'm going to confirm that what I have in state today is what's actually true in the cloud. So I guess I'm mentioning state, I realized I think we kind of skipped over this concept of state. And what's happening under the hood, we execute this program is we generate a state file or a checkpoint file that represents the state of your resources. And in the case of the Pulumi SaaS, we store that on your behalf. You can also use a variety of other state stacking mechanisms. You could store your state in S3, for example. If you use the Pulumi SaaS, obviously you get the benefit of kind of all this stuff I was just showing you around like, this resource graph and, having these quick links and having the full activity history, et cetera, et cetera. But at the end of the day, like the most important thing is having this state checkpoint file so that, we actually know like what exists. And so running refresh goes and compares that state file against what's actually in the cloud, or reading everything from the cloud to see like how does that match up against the state file. And if those don't match, then expect no changes will actually error out and say like, hey, there actually were some changes, so something's drifted in what's in the cloud versus like what we actually thought you had. And that's probably the most common way that we do any kind of drift detection in end user stacks.
Yeah, and I mean, again, I think it's just really cool that you're able to kind of see that kind of upfront. This is how I kind of imagine it is like, hey, I'm trying to commit something to like a repository, right? And then you're like, hey, you gotta resolve these merge conflicts. And so again, it kind of it's just expanding this idea of like instead of just, it's not just code anymore, right? It's infrastructure. And I guess like we'll talk a little bit more about kind of like infrastructure as code but I want Lee to get started on kind of the Lambda container stuff first. But yeah.
But before we do that, Eugene, who are we? What is the show, and what are we talking about today?
This is Howdy Partner, and we are, well, Andrew and I are AWS Solutions Architect, and Lee is the VP Engineering at Pulumi, and we are just technologists who likes to kind of check out like new technologies, how it integrates with like some of our partners, such as like Pulumi, and yeah.
Cool. So let's do this container example. We'll run through the whole example. So we'll create a project called, I don't know, we'll call it Howdy Partner container, and we'll use Python again, or actually maybe we'll use TypeScript since I showed Python. We can come back to Python later if we want, but at least kind of show a couple different languages.
So I think while the dependencies are getting installed, Lee, Andrew, and the audience, like, what are your favorite programming languages?
I'm gonna have to go with Python. I think that's the first one I ever started with. And I kind of always stuck with it, and so it's my go-to.
Yeah, I guess like for me, I probably should say like all 4 of our languages that we support, but I guess personally, no, I do prefer probably Python and TypeScript more. Just like I prefer especially probably TypeScript more than Python even now actually. Like I really just like the syntax of how it works, and that's probably one of the things I really like. Oddly enough, like this is going to sound weird, a lot of people, I really like Lisp. I used to do a lot of Lisp hacking way back in the day. I don't do it anymore, but like, part of my like formal education background is in first order logic and like knowledge representation, and like a lot of that actually like is great in Lisp. And so I still have like a fond place in my heart, I guess, for Lisp. But anyhow, like we're not going to be doing any Lisp or Clojure today. So if we run the same thing I did earlier for TypeScript, you can see here's a very basic TypeScript program. It's going to do the same thing we did earlier, but obviously we're not going to do that. So let's delete this. What's going on? All right. So what are we going to do? We are going to. What do we need? Let me close this. We need to first create that image. And so I'm also going to import Docker. I believe this is imported in our, oh, it's not. Okay, so let's include that. So let's npm install that. Okay, so now we have that. And so let's also create the actual application we're going to run. I'm going to copy kind of an existing thing I already have. So one of the most annoying things, at least in my past experience, at one point I was building something computer vision related. And one of the most annoying things to get into Lambda as a layer is FFmpeg. Because like FFmpeg it's native code. It has to run against a certain like architecture. It expects all these certain things, and so getting like the right FFmpeg binary as a Lambda layer was always like not easy. But with the container support, it's like way easier. Like you package the whole container, you know it's going to work because like you built the container image yourself. And so let's have this FFmpeg container, and we'll make this Docker file. And actually, like I think this is going to look a lot like what Andrew had, where we're going to first. I think this is the right path, right? And I think the tag you used was 12.
12, yep.
So we can do the same thing there. And I'm just going to copy some stuff that I've used previously, where basically like this part is not quite the same as live, but I think some of this is like annoying enough that I don't want to like recreate this live. So we need a few utilities to install FFmpeg. We need so the space image doesn't have tar, XZ, or unzip, so we're gonna install those. And then we also actually are going to use the AWS CLI as part of some of the stuff we do in our Lambda function. And then we're going to install FFmpeg. And so we're going to curl this well-known FFmpeg URL, and we're going to untar that, uncompress it, and also just finally move it into a path that we can use. And then we're going to create a function. And so this function doesn't exist yet, so let's create that. Because this part is all like the not interesting part, so that's why I'm kind of copying and pasting here. This function is not going to do anything too special. Like we're going to really simple like define this like run function, and it's going to take this handler, and the handler is going to look at the event, assuming it's an S3 event. We're going to look at the object's key in the name. We're going to take that name and find the first underscore, and then we're going to basically use that as a way to indicate to us what frames we want to extract from the file. And so we're going to basically do all that and then spit out that thumbnail into our bucket. So basically this function takes an S3 object, assumes it's a video, runs FFmpeg over that video to extract a frame from a particular timestamp based on the file name that you pass in, and then save that thumbnail file in that same bucket. So this is all the uninteresting bits, I would say, at least as far as we are concerned for today's example. So we're going to copy that into the function directory, and then we have this handler here. So this is handler. And so this is, again, very similar to what Andrew showed earlier, albeit slightly more complicated because we're doing a little bit more in our function than hello world, but more or less the same idea here. Yeah, so what do we want to do next? Let's actually, we actually do need a bucket. So we'll have create a video bucket, and we'll call this, and so you can see again, we have all this nice completion going on. We'll call this just bucket. So that, again, very simple example. And then in Andrew's example, he needed a ECR repository to actually push his image into. And we can actually define that in code here as well. We'll call this, I don't know, my app. And oops, I have to call new. And so let's just make sure this works. So we run Pulumi up. And so you can see it's going, the preview says, hey, we're going to create a bucket, we're going to create a repo. So let's do that. But pretty soon after this, I'm going to start doing Pulumi up -- yes, so we can skip the preview step. But in case people think, I'm going to start YOLOing it more for the purposes of but like in real life, you should first confirm what changes you're going to make to your infrastructure before you do it, or have it hooked up in some kind of CI/CD process to confirm infrastructure changes. Just want to make sure I'm clear. I'm not advocating on your show, bad practices. Yeah. So actually, let me do something else here.
But to be fair, if this is our own personal project, this is what we always do. It doesn't really matter.
Yeah, let's be honest here.
Yeah, we're all doing this, right? Let's not kid ourselves. One thing I guess I should point out is what I could. Well, I'll keep going, I guess. But the next thing we will do is actually push into this repo. But I started doing this and I realized actually I had this AWS X thing in here. And so I'm going to actually use that, but I wasn't using this before. So AWS X is a library that we built at Pulumi that is a convenience library that kind of abstracts away a bunch of things related to how to use some of the AWS stuff. So for example, here I have this repo, and the next thing I actually should go do is I should go create this, I should go create a Docker image. And it would be new Docker image. And I'd have to give it a bunch of arguments around the build and what to do with the build, and then how to push it into the repo and all this stuff. That's actually abstracted away for us in AWS X. It's a one-liner in AWS X. So I'm just gonna do that. And so we can do this, and we can say build and push image, and right. So we'll call this my app again, and here we're going to give it some arguments, and in this case, we're going to give it a Docker context, and it's going to be the build fmpeg directory. And so now we'll run Pulumi up again, and you'll see that actually it's going to ask us to I expect it's going to ask us to delete the old repo, because this is a completely new resource that we didn't have before. Yes, you'll see the repo I had defined before. Since I removed it from the program, we're going to delete that. But instead, we're going to create this convenience thing that kind of hooks up a bunch of stuff with a repository with its own repository and its own lifecycle policy. So we'll say yes. And as it's doing that, what's actually going to happen also is it's going to take what's here and build that image. You can actually see building image. It's pulling the layers and doing all that fun stuff, and it's going to push that back into the repo.
And I just want to say, if for the people that are just joining us, we're here today with Lee Zen, VP of Engineering for Pulumi, and he's just kind of walking us through how to kind of create a Lambda container image using TypeScript on Pulumi. And again, cool thing I want to mention is just kind of have like a mini little documentation in your autocomplete so that you know exactly which parameters to put in.
Yeah, super nice. I mean, one of the great things about working in a programming language is just all the ecosystem things, right? I kind of glossed over it, but you have the inline documentation that you expect that you get from any kind of SDK, and then also I mentioned AWS X as this kind of higher level abstraction library where we've encapsulated a bunch of the functionality, this function build and push image is, and we can click into it. And in the actual JS, there's a bunch of stuff that it's doing, right? And we kind of we don't have to worry about how that all happens. It sets up a repository, it sets up a lifecycle policy, and then finally it also uses this compute image thing that's actually building the image and then pushing that. We don't have to worry about all of that. It's all encapsulated. Now it sounds wrong, but it's encapsulated away for us in this little function, and we don't have to worry about how. And that's the beauty. That's why people use programming languages, right? So you can get that abstraction, so that you can hide those things away, and someone's done it for you. So that's great. I think my connection's lagging. I just realized because it's pushing to ECR as I'm talking.
No, it's okay. And yeah, so um, I think this might be a good time to kind of talk a little bit more, I guess, about like infrastructure as code, since essentially like a lot of what you're kind of doing is, you're provisioning infrastructure with like what, 3 lines in 10 seconds, with some keystrokes. And you're also kind of just introducing the fact that like AWS is like another abstraction layer where, hey, like this is something that will make your life even easier, right? And actually, I guess that's it for the IAC talk right now. Lee, I'll let you get on with a little bit more, but we'll go back to
Sure.
definitely more about infrastructure as code later.
Yeah, so you can see, it pushed the image into the repo, so we can actually, again, run Pulumi console. We can go see this particular stack. And if I go look at the resources, it did create this repository. If I go click open this repository in ECS, oops. Why is that? What if the link was wrong? Yep, let's do this one. Yes. So this is the one we just pushed just a minute ago, and so this is the tag and everything got pushed here. So that's great. So that all worked. And now what we want to do is actually run this image as our function, right? And so we can do video bucket, and there's a convenience thing here too. You can see there's an on event, on object created, on object. So we want to do on object created. And so we'll call this like on new video or something like that. So every resource has a name. So in this case, we're calling this resource on new video. And you can see the next thing it wants to take is a handler. And so we can give it this handler. And the thing we want to do is give it the image URI. So this will be the image we just pushed. And so we can refer to the image value. So this image value is actually the full string, basically, that represents the ARN of the image, or the URI of the image, rather. And then it needs this needs a role, I think. Yes, okay, we should create that. So we're going to create a role. We'll call it like the thumbnailer role or something like that. And it's going to need to. That's right. So we kind of need to like set all this up. So we need to give it a assume role policy. So again, we have all these like nice convenience things built into here. So we'll give it. What is it? This. Okay, so now we have a role that Lambda can actually use to execute our function. And we'll give it this role. And then I think probably give it a timeout. I think that's probably all we need. Let's see. Oops, let's go ahead. Oh, it should be an ARN. And let's go with this. Number. I'm not sure why it's complaining about that. Let me do this. Okay. Oh, I see. So this is a case where I actually have to use apply. I think that should work. Let's see. Sorry, I'm just trying to massage these types to be the same types. So, okay, let me back up to here and kind of describe what I ran into that I think is confusing. So you can see here this image value that I'm getting back is for some reason that my type completion thinks it's a input string, which it shouldn't be. This should be an output of string because it's like the return type for the image. So I wonder if there's something wrong with my IDE setup. This is why I guess I shouldn't do things live. And so like the type checker is just complaining that it's not expecting that like input string is not assignable to output string, which is true. Like it shouldn't be like that. It should not be assignable like that. But I actually don't think this returns that. So that's kind of odd that it thinks that. Give me 1 sec to try to debug this. Huh. Trying to see if I did something odd here. Oh, okay. I know what I did. This, okay. I think, yes. Okay. I can't create it quite like this. I need to actually, let me do something else. So let me create a function. So, okay, here's what's going on, and here's why I messed up. So on object created, this handler is actually like, this event handler is not the like exact right type that I'm supposed to be using here. So let me delete this and move this out. What I do want to do is I want to create a new Lambda function and pass that function as the handler. And so like kind of I can't quite inline the thing that I wanted there. So let's do that. I think this should work instead. So if we do this, there we go. So now, okay, so problem solved. So we have this actual function, which is defined by the image along with the role that, and get rid of this now too. So now the types should all be correct that it expects. And then I can pass this thumbnailer in as the handler. So the types were just slightly off. Like you can't just pass this in as like it's not expecting that. It's expecting either an inline function code, which I'll show next, just to show you kind of how that might work. But it's expecting a function or if I look at the type, this event handler type, I forgot is actually like it's either an inline function or an actual function, but not kind of like a weird combo of the two that I was trying to define earlier. Mm-hmm. So okay. So now that we have that figured out, this I think also takes some additional parameters, and so we can choose to only have it work against certain events or certain prefixes or suffixes. So we'll do that and only have it work against MP4 files. Okay. So the other thing is this role probably needs a policy that lets it. Otherwise, it's not going to be able to do anything. And we'll give it a manage policy. All right. So now, okay, so now we have all this. And I think that should be like everything. And we can run this. So let's run Pulumi up. Let me do let's do that. No need to check the preview. We're just going to say yes. And let's also, I realize I don't have a video handy. Let me just dig around on my machine.
You know, if YouTube didn't have like the thumbnailing function, this would be a great piece of code for a lot of YouTubers.
Yeah. Let's see. I know I had some random video I was using for this kind of stuff. Is it this? Yeah, okay. Let me bring this. Oops. I forgot to set the, so one of the nice things is you can also get little things like that. So this should be image. Otherwise, it doesn't know that it's a image. Okay, so I'm going to use this sample video. So it's just like a waterfall or something. And so we're going to copy that over. And let's see. So we have all that. And the other thing we have to do is make that sample actually like the right file set, the right file format, the right naming format. So you can see here we said it's underscore, and then we kind of figure out the frame position from that underscore thing. So we will do that. So if we rename I think that's all I need. Let's say like 5, 3, something like this. And let's wait for this to finish. So we push the image. Now we're creating the function that's referencing the image. I guess we talk a little bit more about IAC if you want. Well, oh, never mind. Just kidding. So let's do AWS S3CP. And so we can do this. Pulumi. Sorry, actually, let's do this. So let's define that output. So we'll export. Oops, it's called video bucket. So this actually won't change any resources. All this should do is it should basically just give us an extra stack output, and that way we can use it for stuff, which is what we're about to do. Although it will go through the build image step again, but okay, so now we have this bucket ID. So now what we can do is, oh, I should skip preview as well, but that's okay. So now we can run and we can put this into Pulumi stack output. So that references this basically, so that this will actually bring that string in. And so you can see we uploaded this sample file to here. Great. And so if we go back to our resources, you can see we have this function now, so we can pop this guy open. And so this is, you can see actually it's also hooked up to the S3 notification event from the Lambda console. So we know we did everything right. We can go look at the monitoring, see hopefully that it ran after we uploaded that file. Let's look at the logs in CloudWatch. See if we did anything wrong, as I'm sure I did, because this is live. So you can see actually it ran the ffmpeg command that we expected it to run. So it ran ffmpeg against, it extracted that O3 from the file name and tried to stick it into sample.jpg. And then it copied it. So actually this worked. Surprise. So it actually copied it here. And so if we actually go back to our console and we do AWS S3CP, oops. If I open sample JPEG, hurrah, like it worked. And so
There
with
you go.
with our code, we kind of walked through basically something very similar to what Andrew was talking about, but kind of we did it all in kind of one program together where the program actually itself is doing the build and push. So that's all happening up here. I guess we kind of walked through the program again. We created this bucket for uploading the content for processing. We created this build and push thing, which creates both an ECR repo, builds the image specified by the Docker file in this context, and pushes it to that repo. And then we created a role because you need a role to execute your function. We defined that function with this role, which has the full Lambda access permissions, referencing this image. And then we basically said, hey, on new video, where we're basically looking at the video bucket where for every new object that gets created with a MP4 suffix, it's going to actually execute this thumbnailer function. And then when we uploaded that video, like we just did, and we went to the thumbnailer logs, we can see that it executes that function and does what the image specified it to do.
Mm-hmm.
So that was kind of like what I wanted to run through as far as like the basic example of what Andrew kind of the equivalent of what Andrew showed. I think we could do a couple other things if you guys want, if we have time. I guess it depends on kind of how we're doing on time here.
Yeah, so we still have a bit of time, and I think right now we can kind of just like take a quick break a little bit. Well, not break in the sense of us going off air, but more kind of talking about how just kind of being like I really want to go back to the whole idea of like IAC, right? You're kind of sharing how. You're kind of sharing how like you're able to kind of create like all the roles. You're able to I mean with Pulumi itself being able to kind of abstract and be able to push, kind of have that AWS X ECR build and push image, right? I guess like from not just I guess not from a personal like development standpoint, but I guess from like a company standpoint, right? Like why is IAC so important? Or becoming more important? Why is it becoming like more widely used? Like why is Pulumi blowing up?
Yeah, it's a great question. I think there's a number of reasons, right? And it's all about productivity. Like I think it all comes back to productivity, but like that productivity gain and unlock happens in a lot of ways. So I'll talk through some of them, and we can talk about more of them if people are interested. But like one of the big ones for me is like everything we just ran through in terms of the fact that it is a programming language. That's a big productivity boost. Like all the things we just used, like for example, like this is an enum right here. So you don't have to go hunting for like the right string. You're going to get the right thing because you're using the enum. That's one example. Another is like some of the abstractions we talked about, and being able to compose those things yourself. So like, for example, a lot of our companies that use us build their own internal abstraction layers of like, hey, at company X, this is how you are supposed to use these things together. And so they build a higher level component that, wraps a bunch of things together. Like, you can imagine like a VPC with the routing table with all the routes and things like that. Like, hey, use this as the building block for what you as an application team go do. It's kind of vetted and approved by the security team. It's approved by, the internal IT team. Like everyone's on board with it. And that's a productivity boost. And so there's all these kind of like things that you get from a productivity boost perspective that makes this super attractive. We can also talk a lot about like what you and I talked about earlier around how it's all like, because it is code, it can be treated as code. And so you do get all the benefits of things like code reviews and being able to actually have, the full Git history of what's happening, et cetera, et cetera. Mm-hmm. Another cool thing about the fact that it's code, which we could do after this is kind of show how you can test this. So this is testable. So you can do unit testing with Pulumi, and you can test that the inputs and outputs that you're wiring up are what you want them to be. And similarly, you can run integration tests. And you can, as part, like, for example, at Pulumi ourselves, we run tons of integration tests where we have stacks. We bring up the whole stack for real using the integration test framework. It actually creates the resources in AWS for real, and then it tears it down at the very end. And so you can run like a smoke test to make sure like, yep, the code I just created is going to work. It is going to create the resources I expect it to create. And it's all and you can even run additional verification like, yep, I can ping the endpoint returns a healthy thing, and then tear down the whole stack at the end. One last thing, I guess, I say something, and kind of related to that is policy as code. And so I'm not showing that here either, but lots of companies from a productivity perspective gain by using policy as code, where as an organization, you can have a certain set of policies that are expressed, again, just as code, that run against your stacks, that validate that those have what they are configured or set up a certain way, or the way that the company expects them to be. So for example, like, hey, all resources should have tags, right? And all resources should have this set of tags. They should have an owner tag. It should have a department tag. It should have a cost center tag. You can do that. Or you could even have a policy that says, hey, like, no buckets should be publicly accessible, right? That can all be auditable via policy as code. And someone can go define that code. And again, this helps make developers more productive, because now they don't have to think about, am I complying with the policy or not? Am I using the approved components or not? People can share code between each other. There's all these things that just kind of make people so much more productive when they use infrastructure as code.
You don't have to wait for the SOC 2 audit to actually happen to realize that you're not compliant, your solution is not compliant. Cool.
Actually,
thanks for that. Thanks for that.
I think we have a bunch of questions in chat, actually.
Sure.
So in the first one, I think we may have missed is why use Pulumi over Amplify plus Lambda triggers? And I think we talked about this a little bit at the start of the show. But I guess just to tackle that one, Lee, why use Pulumi over something like Amplify combined with something like Lambda triggers?
Yeah, I mean, I think it's fairly different. I think Amplify is targeted toward a very specific use case,
right?
Around building a kind of like, typically, like, I think Amplify is more targeted toward like front end applications, and kind of more targeted toward a specific kind of way of doing things. Pulumi is kind of a horizontal platform. Like, you can do anything with Pulumi. And it's not targeted toward any specific use case. It's not targeted toward web applications or anything like that. It's really targeted toward helping people bring their application into the cloud in whatever they want, in whatever language they want. Like, it's not to say you can't use, in fact, you can use the two of them together. There's nothing preventing you from doing that. So in many ways, like, Pulumi works well with a lot of existing frameworks, including Amplify. And
then he had a follow-up question. I think we all saw this question coming. But the AWS CDK versus Pulumi, that's always a fun one.
Yeah, so I think I talked a little bit about this earlier. They're both great. Like, I'm not gonna be like, hey, like, Pulumi so much better than CDK or anything like that. I think they're both great. I think it really depends on what you want to do and what you're trying to do. I think the language coverage is slightly different between the two frameworks. CDK does have Java. I don't think it has Go. So there's some things like that are slightly different. But kind of fundamentally at the lower level, CDK ultimately executes as CloudFormation. And this kind of goes back to this other question: does Pulumi use CloudFormation templates? And the answer is no. Pulumi doesn't use CloudFormation templates. So that's probably one of the biggest differences, is that Pulumi has its own execution model, its own execution engine that is not CloudFormation, and that actually lets you do things a certain way that you can't accomplish actually in CloudFormation. So there are things that you can write in Pulumi from an expressivity perspective around, like, provisioners or things like that are much harder to write in CloudFormation because of the fact that the execution model is different compared to CloudFormation.
Yeah, that actually hits one of the other questions I was asked, and I think one of the other questions I think is kind of interesting is zero ops going? Is like the tech industry kind of trending toward like a zero ops model? And I guess I kind of want to say something first. I want to see if Lee agrees or disagrees. I don't ever think like ops is ever going to be totally removed. I think ops for different companies are going to be different things, and I also think that like engineers are kind of now really sharing like a lot of like wearing a lot of different hats. So I think like a decade ago you had specific roles asking for software engineers and tests and like software engineers, and now like that's not really the case, right? Like you really should be testing like what you're creating. And I think the idea of ops right now, because it's now becoming more streamlined and you have like solutions or SaaS platforms that kind of helps with like kind of unifying like increase the productivity of like different teams. You kind of start having like if you're developing code, you might also be like, hey, I'm on this team and like our current like CI/CD pipeline isn't really that great. What can we do to kind of improve that, right? Like you're going to be constantly kind of learning. So I don't think you're ever going to have like zero ops, but you might end up in a situation where like an operations engineer might be kind of like a software engineer, and kind of like vice versa. And Lee, I'm going to throw that back to you.
No, I totally agree. I think it is that vice versa, and that is why I think Pulumi is becoming so popular. Like you asked, like why is it blowing up? I think it is because it helps bridge that gap. It's not about ops versus application teams or anything like that. It's everyone is trying to work together to accomplish the company's goals. At any organization, and by having a thing like Pulumi, where it's a language that everyone can understand, you can pick. A lot of times, like your ops team, quote unquote, will understand Python, and so will your application development team. And so you can have a common language that both teams understand, or like they can even use their own languages, right? Because you can reference stacks from one to another. And so, but to be able to use real, regular languages, and then on top of that anyone can use, and then on top of that, what we are seeing is that what are quote unquote ops teams are really IP creators actually. And so it's not so much about, hey, like, let me maintain the infrastructure for you. It's about, let me build the abstraction layers for you, or let me help you define those abstraction layers. So like, AWS X in some ways is Pulumi's own opinionated way of talking about some things. Like lots of companies are building their own internal versions of this where they're saying, hey, like the way we expect you to use ECR, the way we expect you to use ECS is this way. And so they'll have a higher level component library that is, Kubernetes cluster or something like that. And it's built up of a certain number of things that have certain definitions that are conforming a certain way. And so it's that team, that infrastructure team, that is really developing the definition of that and vending libraries. They're vending libraries to other teams saying, hey, use this library to instantiate that cluster. Use this library to get the VPC you need. So for example, like you could totally imagine like, hey, all VPC should have flow logs enabled and should be instrumented this way and that, and should have NAT gateways set up this way. Like at a large organization, you should be able to do something like import from company VPC, and then you would type in like something like this, right? Something like whatever, and all of a sudden like this thing is being defined by that infrastructure team, and all the underlying things that exist about it, like you as an application team don't have to care about it. It's just done for you, and it's you're off to the races.
I guess one question I had is kind of changing direction is, I guess what common blockers have you seen from, folks that are trying to adopt infrastructure as code and more of these DevOps best practices? What are some of the main blockers that you've seen based on customers or folks that you've talked to in the industry?
Yeah, that's a great question. I think I don't know if I've seen like a common blocker in terms of adopting it like per se. I often see like the reluctance, I guess, I've often seen from smaller companies or startups where they haven't lived through the pain of not doing infrastructure as code. So no, what I mean by that is like, yeah, I mean, I've talked to, it's just they haven't lived through that operational pain yet of like not doing it.
Sure,
and
sure.
So, I've talked to someone who's like, yeah, like, why do I need this? I go into the console, I define a bunch of stuff. If I need a new server, I spin one up. If I need, whatever, I spin it up on the console. And they haven't quite gotten to that level yet where like, something doesn't work the right way, or they have to go reproduce something, or they have to go create another dev stack or something like that. and like they're doing it by hand, they haven't lived through that pain quite yet. And so in some cases, like when I talk to some of those people, they're kind of like, what, what you're saying sounds great, but it's like, it sounds like a lot of work to go define this thing in code when it takes me a few clicks to like click around and I can click my way there. And they just haven't seen like how many clicks you really have to do sometimes, especially when you're doing it repeatedly or you're trying to run this in a CI/CD kind of environment. Like they're more like in still kind of ad hoc mode, and so they don't really know yet what this really means for them.
I mean, I think like, as like your company scales, right, as it gets bigger and you're hiring more people and more code is being written, that option of kind of streamlining everything of like, programmatically doing all this is a lot more appealing. And I guess like, my personal story with that is just kind of coming into like my last job, kind of doing like something around like cloud migration where like if you wanted to do everything at an enterprise level and you want to migrate things like by hand, like ad hoc, like feel free. You're going to be constantly logged out of the AWS console because your session is going to get expired, and you're going to go through that like a whole bunch of times. And so, yeah, I mean, that's a really great point. But yeah, we have another question right here about the smoke test that you were kind of referring to using IAC. Talking about smoke tests, how does it work with SSL generation against ELBs, etc.? The problem with Terraform, let's say you need SSL to be generated for a ELB. It will fail to build a load balancer as a SSL could take a few hours to generate. How can you handle for this?
I'm not super familiar with the exact problem that's being described. Like typically, like when we do something like this, like even for our own stacks, we use ACM to generate a certificate, and that certificate generation happens fairly quickly. Like there's actually if I go into this here, like typically what you would do is you would do so you create a new certificate this way. And I don't recall, so this takes some options, like you can give it a domain name, and then later on what you'll do is you'll do validation, and you'll basically do certificate validation in between here. So you'll set up, which I won't show, but you would do something like record. And so you'd input the right stuff here to create that record for the validation. You would then run this, which creates a resource. It's a fake resource actually that that checks that ACM actually has validated that the records are correct, and so that the certificate is correctly issued. And then you could then, with your load balancer, you could, you could then attach the certificate at that point of the load balancer. So that's typically how we would do it. Or, actually like here, you could do it this way, or against, CloudFront distribution as well, or whatever you need that certificate for. So that's typically how it works. And typically, like, I've never seen this take hours. Like typically this is on the order of like a minute or two to generate the certificate, create the records, validate that the records are good, that the certificate is issued, and then to attach it to whatever resource you're attaching it to.
Okay. I think.
Yeah, sorry if that.
I think that does kind of answer the question a bit. I think uncodable just kind of referring to like, what if there is like, what if it does take like a couple hours for a certificate to kind of like, be applied to whatever. But I think
yeah, it's a good question. I mean, I think at that point, I guess I've never seen it take 40 years. I think the cases where that takes that long is typically like if it's not through DNS validation, but through some other validation mechanism. And in those cases, like your stack is going to be stuck, I guess. Like it'll create everything. So I guess this is a good time to talk about the Pulumi model. Like we build a resource dependency graph, and like it'll have created all the parts of that graph up to that point, and then it'll stop creating things because it can't continue, obviously. But that's kind of how it would work. Is obviously the rest of the graph is now like unable to be created because anything dependent on that certificate is not going to be able to be created. And so what would happen, I guess, at that point is you would wait for the validation to occur, and then after the validation is complete, when you go run Pulumi up again, it'll go create the rest of the graph that it needs to. But again, because it's a desired state model, it knows what's already been created and knows where it needs to go, and it'll just create the things it needs to or modify the things it needs to get to the right place.
Gotcha.
And then Pulumi will actually generate like a source map, right, in the UI after everything's been completed.
Yeah, so I think, like as an example, like you could, you can look at this.
Right. Yeah.
This is that graph of kind of how all those resources are related to each other. Yeah.
Okay, and then I think another question we may have missed is what issues have people come across moving from tools such as Terraform to Pulumi?
That's a pretty broad question, I guess. Like, I think it really depends on what you're coming from and what you're trying to do. I mean, typically I've not heard any real like things that people miss out on when they come from a tool like Terraform to Pulumi. Yeah, I guess in many ways, like Pulumi is just generally more expressive than Terraform, so people aren't really missing many of the tools, and they're actually getting a lot more in the way of things like unit testability or things like that, where there's just a lot harder to do actually in the Terraform ecosystem. One of the other big things that people get coming from Terraform to Pulumi is, we have this thing called Automation API. So everything I've been showing so far has been using the Pulumi CLI, where I'm running like Pulumi up and stuff like that. You can actually also programmatically invoke Pulumi through like not having to really use the CLI itself. And so let me just see if I don't have it on my machine right now, but if I bring up like, see if I can find an example of this. So you could write code that looks more like this, and let's see if like something like along these lines, where you create a stack. So like earlier you saw me run Pulumi stack init. You can also just programmatically run Pulumi stack. This is like the equivalent of running Pulumi stack init on the command line, but like in TypeScript code. Earlier you saw me run Pulumi up on the command line. You can also just do this in your TypeScript code, and then at the very end of all this, like you could run ts node, index.ts with this inside it, and it'll do all the same things actually. And so like you can treat Pulumi as a full programming model, not just as like a CLI tool, but like you can also just use it and you can mix and match any code with it. And so one of the cool things with doing something like Automation API that is much easier to do in Pulumi compared to a lot of other tools is kind of stack orchestration. And so here, like you can imagine defining multiple stacks, orchestrating them, doing things between stacks, passing things between stacks, doing whatever you need to do, and coordinating all this. Like you can imagine, one stack per. We talked about microservices earlier. You could define multiple microservices in your program, and then coordinate how those come up, what they're actually executed against, et cetera, all in one program, and then have Pulumi kind of take care of all of the infrastructure provisioning for them under the hood.
Sounds like a great disaster recovery strategy.
Yeah, I mean, it's cool because like, a lot of times it's like, here's an example where it's like, it says create our table, right? Like, how do you kind of hook up some of these applications that are kind of still infrastructure oriented or ops oriented things, like with infrastructure as code? Like, how do you run a database migration, right? As part of defining your stack. Like Automation API is a great way to help you coordinate that, where you can first bring up the database stack, run the migration against it or whatever it is, and kind of have that coordination between things before you do something else, right? And kind of have all that defined all in code. I think that's kind of one of the fundamental tenets of what we do, is kind of defining it all in code so that you can actually reason about it because it is just code.
Right on. So I think that is all the questions we have from the chat. Lee, I know you mentioned earlier that you had some other projects, and I know we are now about like 20 minutes away from our cutoff time. Do you think there's anything cool you can show us like in that time slot, or do you think a bit more time is needed?
It's probably tough to show us anything super like huge. I'll mention one other thing, I guess, that I didn't show earlier, like where I kind of like tripped myself up actually. So when I wrote this, I tried to start like writing stuff here in this. And actually, like what this is you can pass it a function like we did earlier. You can also just pass it code. And so the way you could do that is you can do something like I recall the trying to remember the syntax. I think it's like something like you can just inline the code like this as if we're writing a function. And yeah, this should like that. Yep. And so like this is the actual event you're going to get. This is a bucket event. And so for the bucket event, it's going to have records. And so I think it's, this is again live, so I hope I get this right. Let's say like I think I want to do event. Oh, it's S3. Yes. Okay. This is the event, and it's going to be okay. Okay. Remember that as an object. Okay. So we can let's just do this. Right. No. Okay. That's fine. Okay, so what this is going to do actually is this function we've inlined. If it's what's going to happen is, and let's actually do the same thing with the suffix. Okay, so what we've defined here is a new handler for this bucket. So every time there's a new object created in this video bucket, it's going to just run this function as a Lambda. And it's going to run against any objects created with the .jpeg extension. So let's run Pulumi up to update our stack.
So that inline function right there will be its own Lambda function that will...
Yes.
Okay. That's another way of Lambda development.
Yeah, so this is like a super fast way to do Lambda development in Pulumi is you can just inline the functions. And so you can see here when I did this on new thumbnail, it actually ends up creating this event subscription. It automatically creates a role with a function with the role policy attachment and the right permissions to execute that function.
That's amazing.
And so
yeah.
Yes. Yeah, and again, this is all about like abstraction, or like why should you care about those things when all you care about is like, I just want to run this. And so it's going to go create all those things.
And actually, while that's creating, there's another question. Can you create dependencies based on other resources? Let's say you require an ACM certificate to be created before creating an ELB. Like the ELB depends on ACM.
Yes, yeah, the answer is yes. I didn't share that earlier, but there's a thing called resource options. So if I like go up to, I don't know, here, this bucket, let's pretend that I'm doing it against this thing. I'm now in the, if you look at the signature for this, you give it a name, you give it some arguments, which I've given it basically an empty set for the arguments, and then it takes some resource options. And in the resource options, one of the options is depends on. And here you could say it depends on takes some bag of other resources. So I could give it, the ELB, or I could give it the certificate or whatever it is that I depend on. And so this resource won't get created until that other resource exists first. And that hopefully answers that person's question. So yeah, so this all finished. And now actually, if we go ahead and we run, let's do this. So we're gonna upload this test JPEG, which is just actually the sample, but at least that way it looks like a new object. Oops. So we'll upload test to here, so that hopefully means that our function ran. So let's go look at that.
And just FYI to the audience members, we didn't know what Lee was exactly going to do. So my earlier example of lambdas and S3 buckets and videos and whatnot is totally not planned. Just kind of realized that.
Yeah, actually, it's funny. It was not planned. I guess we kind of talked about the same thing. So yeah, so this was the new function that got created on new thumbnail as we defined just here. So if I pop open this function. Oops. You can see a couple things. One is it set up bringing up, and actually two is like this is the serialized version of that code we just wrote earlier. So you can see here, this is actually maybe make my browser a little bit bigger, but this is exactly the code we just wrote earlier to log the event. So this is how that inlining worked. Is it serialized this code and stuck it into this Lambda function. And if we go look at the monitoring, if we go look at the CloudWatch logs, hopefully it actually did what we said it would do, which is it should just log the thing, which it did. So here we said, hey, log the object when a new one is created, and there's test.jpg, so we can like show how that works again in real time. So we pushed foo.jpg. If I refresh this, we should see. This is why I shouldn't do things live, but there it is.
Might take a bit. Yep.
And so kind of like, again, just like super simple, like a few lines of code here, we're able to define that handler and have it automatically start operating against new objects that show up in this bucket.
Cool. I think that last thing you showed us about like inlining a Lambda function.
Yeah, that's pretty
incredible.
Yeah, I figured with a short amount of time, that's probably like a fun thing to show, I guess, in the short time that we have.
Yeah, and I mean,
you actually all sorts of cool stuff. Like, again, because it's all like languages. Like one thing I didn't show, I guess, is like you can also do this, which is let's see, I think it's under ECS. Yes. So you can also do this. And so what this would do if I, if I did this, this image that gets defined, what this actually does is it lets me write like, and this would create an image, push it into an ECR repo with this function as the actual handler for that image. And then I could run this as a task within ECS.
Wait, hold on. So basically what Lee just did was he just did everything I did in basically three lines of code. That's that's pretty cool stuff. I'm not gonna lie.
And so this is a little bit different from the thing we did earlier where, where we're defining an image and using it as a Lambda. This is actually defining a function as an image. So it's kind of like the reverse. This function ends up running within this image. This gets built into an image, and then this image is then executable for. It doesn't. So you'll notice like what I didn't do is this, because of the way this works. Like this image that gets built, it doesn't use that same base image. It's not going to use we don't get to define what the base image is here.
Mm-hmm.
So like it's not going to actually, you wouldn't be able to hook this up to a Lambda function because it doesn't have all the right things baked into the image to do that. But it is viable to run completely if you want it as a ECS image because it's just a Docker image that gets built out of this function.
Well,
yeah. So actually, like, there's a bunch of cool stuff you can do kind of related to this, where like, there's nothing stopping us really either from taking the image we defined here. Now that we've pushed it, we could run that as an image against ECS as well. And there's a bunch of convenience functions in Pulumi AWS X. We call this library Crosswalk for AWS. There's a bunch of stuff in Crosswalk for AWS where you can run the container images as ECS tasks or services very easily as well.
Awesome. I think this is, so we have one question in the chat that says, ask, can we use Pulumi in local development environments? And I think that's what Lee is kind of showcasing here today.
Yeah, I think.
Oh, sorry. He meant, or they meant with a local container registry.
Oh, I see. Let's see. I personally have not done that. I think there should be nothing preventing you from doing that, in the sense that, like, obviously with all the AWS related things, like we kind of expect to use ECR under the hood. But if you were to use the Docker package that I mentioned earlier here, then you can specify whatever registry you want, including a local one. So there's a thing here like this. And here you could choose the registry, and also you could also choose to build it locally as well. So that's kind of what you would do instead. And then you could manipulate the image in whatever ways you wanted. Eventually, you could also hook that, like this image, you could also, imagine hooking up to this here as well, assuming the registry you push to is an ECR registry.
Got it. Okay. Yeah, so I think we just have about like a couple more minutes left. But thanks so much for Lee for showing us kind of I guess using Pulumi, how easy it is to really
Yeah, this is awesome.
create Lambda functions even in 3 lines and have everything be set up. But also to kind of show us how easy it is to kind of create Lambda functions and push it to an image up to ECR.
Yeah, thanks for having me on the show. I mean, this was super fun hanging out with you guys, building stuff live, making mistakes along the way, and kind of like debugging it, and then kind of really, I do think hopefully people get a sense of like it's all here, just in VS Code, like or any IDE that you use, like it's actually very accessible because it's all just programming language stuff, and you can just kind of see how it's all stuck together and kind of do it all yourself. And hopefully our documentation is fairly easy to follow as well. So if you want a guided tutorial and not do it on your own, like there's plenty of material out there to help you get started.
Solid. So if people want to learn more about Pulumi or follow some of the new things that you guys are adding to Pulumi, where would you direct them to?
Yeah, for sure. The website, our main website, pulumi.com. There's a get started button right up there at the very front, helps you get started with installing Pulumi, getting your first project going, and kind of all that stuff, kind of what I showed at the very beginning. And I think someone else earlier asked if it was like free or if it's open source. Like Pulumi is open source. It is an open source project. You can use it completely for free if you want. We also offer a SaaS that's attached to the product, so you don't have to use the SaaS if you don't want to, but we think it's awesome. We think it helps provide a lot of value, helps provide a lot of stuff I showed earlier in the console around some of these things like understanding the resource and history, stuff like that. But you can use this completely without it as well if you want. So we just want people to really build modern applications in the cloud and to be able to deploy those applications easily using the language of their choice. And so that's our main focus.
And then we actually have a couple workshops in February for folks that actually want to learn more about Pulumi and get more hands-on experience. And so I believe it's, let me pull that up real quick. I think this is bringing a ton of value.
Should I stop sharing?
Yeah, I think we are good.
Let's see. Just pulling
Andrew,
it
you
up.
bring up the registration link?
Yeah, I'm pulling up the date. Just give me a second here. Yeah, so February 17th is going to be the first one that we're doing, and that one's going to be more focused on just deploying microservices in general with Pulumi. And then the next one after that is actually building a Kubernetes platform, and that will be on February 24th. So if you guys want to learn more about Pulumi and get more hands-on experience with them, you should definitely feel free to join the webinars. They are free to join. So yeah, 2 events coming up to learn more about Pulumi. But Lee,
And
if
Andrew,
you remember...
Oh, sorry. The registration link is the big marker one, right?
Yes.
All right, let me just drop that. Sorry, Andrew, go ahead.
Yeah, actually, We actually I guess there's one more question. Is Pulumi multi-architecture?
Don't think I understand the.
Yeah, I don't know if I quite understand the question either. I think he means like multi-cloud. Like, could you use like AWS and like GCP?
Oh yeah. Pulumi supports dozens of different cloud providers, including AWS, obviously. But we do support Azure, GCP, and actually, like, kind of the way we think about it is it's not just about cloud providers who provide compute and things like that, but it's also just about anything you might want to use that is a cloud service. So a good example would be like Okta or like various other AWS partners like Datadog, right? If you're a Datadog customer and an AWS customer, you can use Pulumi to use those two things together and kind of manage all your infrastructure in one place in one program. Container architecture.
Oh, okay.
Yeah, so from a container architecture perspective, like it really, obviously, like for some of the stuff that I showed earlier around like builds, like it is using Docker build under the hood. So whatever Docker build supports is going to do. So like, if you need to do certain things that like you want to use a different build system, it's not going to work for that. But at the same time, like Pulumi is very extensible, right? So you could use automation API like I showed earlier and hook in whatever you wanted from a build perspective. From a container architecture perspective, like whatever image you're using is what you're using. So that should work. Like if you're using a different underlying container architecture, that should be no problem. But there are some things around, like I said, if you're using, depending on kind of how you want to build the image, you may need to do some additional things there.
Right
on. Okay, and then Lee, is there anything else that folks should know about Pulumi before getting started, or anything else that they should be aware of when it comes to all things Pulumi?
No, I think it's super fun to use. Like that, the first time I encountered Pulumi a couple years back was like a wow moment for me because just having spent a lot of time in the infrastructure space, playing with a lot of other tools, like Pulumi really just stood out to me as being, it just felt really natural. So I really do encourage people to just start trying it out and like just see how natural it really is to write your infrastructure as a software program.
All right. And so, Lee, if you remember from the last episode you were on, we like to end this show in a very specific way.
Yes.
So, Eugene, sign us off.
Andrew, I'm going to throw this back to you.
All right. So the three options we have is we have come back here. What was the other two?
I think it's Happy Trails.
Happy Trails. And then, yeah. So, Lee, we'll give you the choice. How would you like to sign off?
I like Happy Trails.
Happy Trails? Okay, we'll do that. All right, so how about on three? 3, 2, 1. Happy Trails.
Happy Trails.
There you go. All right, everyone, thanks for tuning in. Thank you, Lee from Pulumi, for coming on the show. Other than that, stay tuned. We have a lot more content coming in 2021, so make sure to stay updated with us.
Thanks so much for having me.
Absolutely. Yeah.